All right, let's talk about two more equivalences that you may or may not want to memorize. Association is an equivalence that essentially allows you to reassociate specific kinds of propositions, and specifically they're the kind that are a conjunction of a conjunctions or a disjunction of disjunctions. So in the first form, you have A and B and C, where B and C are grouped together, and it essentially allows you to just redistribute the parentheses. So of course you can go, it's an equivalence, so you can go one way or the other. So you can go from A and B and C to A and B and C and vice versa. And the same holds for the disjunction. A or B or C can be substituted for A or B or C. The feeling is one of just redistributing the parentheses. Now, distribution is one in which you actually have a combination of conjunctions or disjunctions, and you allow, you're permitted to redistribute the terms and creating a different main operator. So there's two forms that we acknowledge here. There could actually be others, but it just gets to be too tedious to write them all down. So we have, in the first form, we have A and B or C. So B or C is grouped together. A and B or C, with A being the main operator, is logically equivalent to A and B or A and C. So the main operator on the left-hand formula is and, now the main operator is or. So effectively what you see happening, if you think of it in sort of quasi-physical terms, is that you're taking B and C and redistributing them. So you're attaching B to the conjunction and getting A and B, attaching C to the conjunction, getting A and C, and then making the disjunction the main operator. Or running it in reverse, we would describe it in the other way. And the same exact thing applies to distribution. So A or B and C is logically equivalent to A or B and A or C. Now the proofs of these are not really that interesting, and they're not that difficult. They take just a little while, but they're boring, and so we're going to skip them. But we'll just finish this little mini lecture by doing a proof that actually benefits from using both rules. So let's prove this, see if you can do it. P and R or not S and T, and if P then not R, yields P and not S and T. Okay, if you look at this for a while, you look at the conclusion, P and not S and T, what might occur to you when you look at the first assumption is that not S and T exist sort of right here on this side of the disjunction. You've got not S and T here that we want, and it's sitting right here. And if you think about association, it looks like, you could just sort of redraw those parentheses, couldn't you? So something interesting is going on along those lines. And so maybe what you would want to do is see if you couldn't redistribute these terms so that you got P, something closer to P and not S and T on one side of what would end up being the disjunct. So if you were to apply distribution to number one, right? So you've got the and is the main conjunction here, right? So what distribution is going to allow you to write is P and R, and the disjunction is going to become the main operator, and then P and not S and T. Okay, that's an application of the rule of distribution. So that's what we would write here. P and R, or P and not S and T by 1 and distribution. And now, so we've got a disjunction, and we've got something very close. We could just see we have a string of ands, so we could just reassociate and actually have that conclusion sitting right there. But right now we don't have a way to get it by itself. So let's look at if P then not R and P and R. What is this? Is there any way to create a more interesting relationship between P and R and if P then not R? Well, last lecture we learned material implication. What happens if you apply material implication to if P then not R? Right? So if P then not R by material implication, remember material implication says if A then B is logically equivalent to not A or B, right? So if you applied material implication to if P then not R, taking not R to be B and P to be A, then what you would get is not P or not R, right? So if P then not R is logically equivalent to not P or not R by 2 and material implication. And now this is starting to look interesting again if you know all of your essential equivalences, because not P or not R by De Morgan's is what? Not P or not R by De Morgan's is not the case that P and R, which now, so for and De Morgan's, which now sets up a disjunctive syllogism, and you have P and not S and T, right, by 3 and 5 disjunctive syllogism. And so now really you're home free, except you want to simply reassociate the parentheses by the association rule 6 and association. The book writes this all out, by the way. I guess they don't want to say ass, but that's really long. So we'll just say ASS. Okay, and that's how that works, and we are done.